David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today's topic, factoring out a GCF. Now GCF stands for greatest common factor. Okay, I'm going to take a look at an expansion problem that we did a couple chapters ago. You might have seen something like this. And we talked about this. This was a distributive property. You multiply 3x times x, that gets you 3x squared. And you multiply 3x times 4, which gives you 12x. So expansion is this direction. Now factoring is just going the other way. Okay? So a factoring problem might give you something like this and ask you to factor out a greatest common factor. So what we're looking for is what factor is in both of these that we can take out. And let's take a look. Well, there's an x in both of those, right? There's two of them there, or not two, there's an x squared there, but there's one there, so one of our GCF terms is our x. And then how about the numbers? Well, there's a 3 in there, because that's 3, and there's a 3 in there because 4 times 3 is 12. So we have 3 as well. So our GCF is 3x. So what we do is we factor the GCF out. There's the 3x. And what's left, if I factor 3x out of 3x squared, it just leaves x. And if I factor 3x out of 12x, it just leaves 4. So we can check our work. If you were doing a GCF factorization of this expression and got this, then you could do the expansion, do the rainbow, and make sure you got back to where you started. So factoring and expansion are inverse operations. One undoes the other. Okay, let's do a few examples. You can pause the video at any point and see if you can pull out a GCF and correctly factor these 4 expressions. Otherwise, I'm just going to do them. Let's take a look. What's our GCF in here? There's no greatest common factor between 2 and 3, so we're not going to get a number. In fact, there's only an x. That's the only common factor. So this is going to be x times 2x plus 3. And if you want to check, you can do the distributive property and expand back. X times 2x gives me 2x squared, that's good. And x times 3 gets me 3x, so we're good. Let's try this next one. What's the greatest common factor? I do have a negative 2 in both of these, and I have an x. So I could factor out the negative 2x, right, like that. And then what's left here? This would be x, because negative 2x times x is negative 2x squared. What do I have to do to get a 6 with a negative 2? I have to multiply it by negative 3. Okay? Try that one. Okay, if you saw that your GCF was 4x, you're right, because there's a 4x and 4x squared, for sure, and there's a 4x and negative 20x. So we can pull that out. That's 4x. Now what do I have to do? This is just x, because that gets me 4x squared, and this would be minus 5. Okay, let's move on. How about this one? Give that a shot, see what you get. Okay, what's my GCF? Well, 6 does not go into 21, so it's not going to be 6. But they're both divisible by 3. And there's an x in each one, so 3x would come out. Now, what do I have to multiply 3x by to get 6x squared? That would be 2x. Plus, what do I have to multiply 3x by to get 21x? That's just 7. So that's the result of that one. Okay, these last 2 examples are a little bit more tricky. I notice that students stumble on these from time to time, so I want to take a little time going over them. Maybe first time through, just follow. Don't worry about keeping up with notes. Then come back and get your notes straight. Okay, let's take a look at this one. This is a GCF, but do you see? It's kind of hard to see a GCF in there. I'm seeing 2x minus 5, so maybe that's a GCF, but it's kind of buried under the squared. So our first step here will be to write this out. X minus 5 times x minus 5 minus 2 times x minus 5. So now I see my GCF. There are it's this times x minus 5 and this negative 2 times x minus 5. So I can factor out my x minus 5. This is sort of the tricky step here. And what's left? Well, I have the other x minus 5 minus 2. So that's just going to be x minus 5 minus 2, which that we can simplify to x minus 5 times x minus 7. So definitely a more tricky type of factoring, but it works. Okay, pause the video and see if you can do that one. Fairly similar to this one. Okay, let's see how you did. So we're going to do the same thing here. We're going to break that out to the 2x plus 3's that it is. And we notice that we have the same pattern we have here. We had an x plus 3 times these two other things. It doesn't matter that the other thing is also x plus 3. We're going to be able to factor out one of those. So we pull out that x plus 3, the first one, and then what's left? We have the other x plus 3 plus the 4 that's there. This gives us x plus 3 times x plus 7. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.